What if your Arduino project could actually talk back to you? In this lesson, you'll learn how to use a 16:2 LCD screen to display messages, understand what is happening behind the scenes, and make your project feel much more professional. Welcome to lesson 14 of the Arduino for Beginners series. Let's get started. This is the LCD module that comes with the Mind Plus Arduino coding kit. The kit we'll be using throughout this 24-part series. At first glance, it looks pretty simple. You'll have the display on the front, some electronic components on the back, and a 4-pin connector that makes wiring much easier. If you look closely at the bottom front of the screen, you'll see the text LCD 1602 printed on it. This tells us the type of the display we are working with. 1602 means 16 columns and 2 rows. So a 16:2 character LCD can display up to 16 characters per line, with 2 lines total. Now, even though we call this a character display, each character is not just a single block. If you power up the screen and take a closer look, you'll notice that every character is made from a 5x8 grid of tiny dots, also called pixels. By turning different pixels on and off, the LCD can form letters, numbers, and symbols. Once you understand this, a lot of limitations and possibilities start to make sense. You will also find LCDs in other formats on the market. For example, smaller ones like 60x1 or larger ones like 60x4. They also come in different colors such as green or blue. The core idea, however, stays the same. Now let's flip the module around and look at the connector. You will notice 2 important labels, SGA and SCL. This tells us that this LCD module uses I2C communication. In an I2C setup, the SGA pin is responsible for data, and interestingly, it carries data in both directions. The SCL pin carries the clock signal, which is generated by the master device. In our case, the Arduino board is the master. One of the biggest advantages of I2C is that it allows multiple devices to share the same 2 wires. That means you can connect several sensors, displays, and modules to the same SGA and SCL lines, as long as each device has a unique address. This is extremely powerful, especially for beginner projects, because it keeps wiring simple and clean. If you already have some experience with Arduino, you may have seen another type of LCD, one that doesn't use I2C. Those displays usually come with many pins, and connecting them to an Arduino requires a lot more wiring and configuration. Because of that, many people end up buying an I2C adapter and solder it onto the back of the LCD like this. This adapter typically contains a chip called BCF8574. This integrated circuit acts as an I2C input-output expander. In simple terms, it's what adds I2C communication to the LCD. And by the way, this chip isn't limited to LCDs. It can also be used with LEDs, sensors, and other modules. Alright, that is enough theory for now. Let's get our hands dirty and actually build something. Before we jump into the project, I'd like to thank GF Robot for sponsoring this lesson. GF Robot is one of the top global providers of hardware for makers, educators, and engineers. In their online store, you can find pretty much everything you need for your next project, from motors, sensors, and microcontrollers to single-board computers, AI devices, and much more. If you're planning to build something cool, I highly recommend checking them out. They offer high-quality products at very reasonable prices. And as a reminder, throughout this series, I'm using the Mind Plus Arduino coding kit because it contains everything you need to take your first steps into the Arduino world. You can find the link to DF Robot's store in the description below. Thank you again to DF Robot for supporting this series and helping make STEAM education more accessible to everyone. Alright, let's move on and assemble our first project. Open your kit and grab the following components: Arduino Uno, input-output expansion shield, LCD module, 4-pin cable. Start by attaching the input-output expansion shield to the Arduino board. Next, connect the LCD module to the shield. Connect SCL to A5 and SDA to A4. Also note that this display works with voltages from 3.3 to 5 volts, so it's safe to use with most Arduino boards. Now, head over to the GitHub repository of this series. The link is in the description below. Open the folder for lesson 14, copy the file code -lcd and paste it into your Arduino IDE. Before clicking upload, make sure you've installed the DFRobot RGB LCD 1602 library. Once that is done, click upload. If everything is connected correctly, you should see the message Lesson 14 LCD module appear on the screen. Great, that means our display is working. Now let's take a closer look at the code and understand what is actually happening. First, we import the correct library and create an object that allows us to control the LCD. This object is basically our way of talking to the screen. Inside the setup function, we initialize the display, clear any previous data, and print our message. One very important thing to keep in mind is that each row can only display 16 characters at a time. If your message is longer than that, you need to split it across 2 rows, which is exactly what I did here. If this code still feels confusing, I have a full lesson on Arduino programming basics on the channel, so make sure to check that out if you need a refresher. Now, what if your message is too long even for 2 rows? That is where things get interesting. Instead of showing everything at once, we can create a sliding or scrolling effect where only part of the message is visible at a given moment. This is a technique used in many real devices, from printers to industrial control panels. That is what we are going to explore next. Go back to the GitHub repository, copy the sketch code sliding text, upload it to your Arduino and watch the LCD. You will see a long message smoothly scrolling across the screen. So how does this work? Let's jump back into the code. The beginning of the sketch and the setup function are almost identical to the previous example, so we can skip those and focus on the loop function. This is where the real magic happens. The key idea here is to treat the message not as a straight line, but as a circle. Think of the text as written on a ring. When you reach the end, you immediately wrap back to the beginning. Why is this important? Because it allows us to create an infinite scrolling effect without worrying about where the message starts or ends. Since the LCD can only show 16 characters at a time, the code creates a temporary string called visible text. This string represents exactly what should appear on the screen in that specific moment. A for loop runs 16 times, once for each column of the LCD. On each interaction, it picks the next character from the message using modular arithmetic to wrap around when it reaches the end. This is why the module operator is so powerful here. It guarantees that we never go out of bounds and the text keeps looping smoothly. After building those 16 characters, the code prints visible text to the LCD, then it increases the position by 1 so the next frame starts 1 character later. Finally, the delay controls how fast the text moves. Adjusting it changes the scrolling speed. The result is a smooth and infinite scrolling message. If you are enjoying this project and want to take things further, you might like this. I'm currently preparing a full masterclass on building drones with Arduino. We'll cover topics like flight control, wireless communication, PCB design, and 3D printing. You won't just learn the theory, you will build real drones step by step using our Arduino board. If that sounds interesting, I've created a waiting list. You'll find the link in the description below. Join it if you want to be the first to know when the course is released. And that's it for today's lesson. I hope you enjoyed it and learned something new. In the next lesson, we'll learn about infrared sensors and use it to build a cool project. If you found this video useful, make sure to subscribe because each lesson builds on the previous ones, and things are about to get even more interesting. Also, if you haven't already, go back and watch earlier lessons so you don't miss any important concepts.